Welcome to Chemistry at Honega High School. I'm Brian Brown, and today we'll be looking at our next set of notes dealing with the mole. And today we'll be looking at really what comes next after empirical formula, because empirical formula is really the first step in trying to find the molecular formula of a substance. So once we've established an empirical formula, we're not really done. Because remember, an empirical formula is the molecular formula reduced by some amount. So what we really need to do is find out what that multiple is. So the molecular formula is always some whole number multiple of the empirical formula. And that's really our job, is to find that whole number multiple so we can convert the empirical formula to a molecular formula. So for example, HO is an example of an empirical formula. So the actual molecular formula is some multiple of that. We just don't know what the multiple is. Now, H2O2 is twice HO. So if H2O2 hydrogen peroxide was our molecular formula, that means its empirical formula would be HO, and the multiple that we would multiply HO by to get the molecular formula would be 2. So HOX, what is the X? Well, for hydrogen peroxide, the X would equal 2. So that's really our job in a molecular formula problem, is to find out what that multiple is. Another example, glucose is C6H12O6. It's going to have an empirical formula of CH2O. That's what it would be if I divide everything by 6 and reduced it to its empirical formula. And the multiple for glucose would end up being 6. So if we had a substance and I knew its empirical formula is CH2O, and I knew that the molecular formula was 6 times bigger, I could multiply it out and calculate C6H12O6. So to convert an empirical formula to a molecular formula, all we really have to do is find X. We need to find that multiple. Well, how do we get X? Well, if we experimentally determine what the molar mass is, and we divided it by the experimentally determined empirical mass, we would find out what the multiple is, how much bigger it is. So this is what a typical molecular formula looks like. An unknown gas is found to have an empirical formula of NO2. So that part of the problem has already been done. And a molar mass of 92.0 grams per mole, what's the molecular formula? Remember, we're trying to find the multiple X, and that has to be the molar mass divided by the empirical mass. Well, I know the molar mass is 92.0 grams per mole. That was given in the problem. What I really need to know is what's the empirical mass. Well, I know the empirical formula was NO2, so a nitrogen, which weighs 14.0, plus 2 oxygens, which each weigh 16.0, that would give us 46.0. So the molar mass, 92.0, divided by the empirical mass, 46.0, would give us the multiple. Now, one of the things that sometimes students do at this point is they confuse what they're doing here with what we talked about in empirical formula. Remember, you got the mass, converted to moles, divided by small, and then multiplied till whole. Well, the only reason we needed to multiply by till whole was because sometimes it was a half and sometimes it was a third or 2/3 or whatever. So in order to truly keep the ratio between the moles of the different substances and get whole numbers, we sometimes had to multiply by 2 or 3. Well, when we're doing molecular formulas, remember we should get almost exactly a whole number at this point. So if I get 2.5, I know I did something wrong. If I get 2.18, I know I did something wrong. It should be almost exactly 2 if it's not exactly 2 like it was in this case, or whatever the whole number multiple was. So remember, unlike before, we shouldn't be seeing anything other than whole numbers when we solve for x. And then at that point, we have NO2, and that multiplied some multiple, which in this case is going to be 2, should give us our molecular formula, N2O4. So this must have been dinitrogen tetroxide. So that's how you do molecular formula problems. Once you've established the empirical formula and you know the molar mass of the molecule, you divide the molar mass by the empirical mass to get the multiple, and then multiply it out, and you have your molecular formula. So it was a short set, but that ends our notes over these ideas.